right? So we know the top two reactions, we're looking for the bottom reaction. So we're going to start by trying to find out how can I manipulate the top two reactions to give me the bottom. And so I would start with iron, right? Because we can see up here, iron is a reactant, and I need it as a product. So what can we do with that first equation that gets us closer to the equation we're looking for? Yeah.
You flip the reaction products and it makes the delta H bonds.
Yeah, we can flip it and we might need to do one more thing as well, right? Yeah, we're gonna divide by 2. So we're gonna flip it. And we're going to divide by 2. So I flip that around, I get iron 3 oxide yields 2 iron. And it's okay to have 1.5 oxygen here because I should just write it 1.5 because we're trying to get this to work out. So 1.5 oxygen, and then exactly right. Our delta H becomes positive now because we flipped the reaction. So we went from going downhill to now going uphill. So we're going to have a positive. We have to divide the delta H by 2 as well. So positive 824. All right. What else do we have? We've got carbon dioxide, carbon monoxide. So again, we would take a look and see that right in our carbon dioxide reaction, carbon dioxide is a reactant. I need it as a product. I have it for 2 moles. We ultimately want it for 3 moles. So yeah, this one, they're making this one a little bit trickier than it needs to be. So what can we do with that second reaction to get us closer? Yeah, Mohammed.
Multiply by 1.5.
Yeah, and what else do we have to do?
Flip it.
Yeah, we need to flip this one as well, and we're going to multiply this one by 1.5. So not as straightforward as some of the other ones we've done. So I'm going to flip that, multiply it. I get 3 carbon monoxide plus 1.5 oxygen goes to 3 carbon dioxide. And I have to multiply delta H by the same value. All right, so multiply 565.4 by 1.5 to get a negative, because we flip the sign, so a negative 484.1 kilojoules. Now I can add those together, right? And this is where we didn't have to really worry about that 1.5 oxygens because the oxygens cancel out. They're equal number on both sides, so they cancel out. We're left with iron 3 oxide plus 3 carbon monoxide yields 2 iron and 3 carbon dioxide. Add together those delta H's, and we're going to get what, like a negative 48 basically. Kilojoules for that reaction.
Delta H is 484. Oh, sorry, I'm just kidding.
Oh, it's not
I
negative
think you
28.
said it, but I know I heard it. Okay.
It was like negative 24.
Or yeah, 24, sorry. I know, I was looking at that, and I was like, that's not right, that's 24 and 48, yeah.
Also, is it 260?
It would be 2 significant figures because, let me just write this out before I forget. Right, that's gonna be 24, and then I would say 2 significant figures because in the 1648, there were no decimal places, so when I divide it, there's no decimal places, so when I subtract or add those 2 together, I'll have no decimal places in the final answer, so just 2 significant figures in the final answer is what I would say, based off of that for question 46. So yeah, this one, I think, I mean, you're definitely going to have a Hess's law question on the exam. this one's a little bit trickier in that we had to flip both of them. Okay, that's fine, but it's a little bit odd that, we're multiplying by like 1.5 or, I mean, dividing, that's not a big deal, but it's kind of odd to just have, like half numbers, in there. But yeah, multiply, divide, you flipped. We got the reaction we were looking for that. So yeah, 48, question 46, sorry, I should have -24 kilojoules of energy.